Welcome. Today we're going to talk about chemical reactions. A chemical reaction is a process through which a substance has its chemical composition modified. That is to say that we're changing the number of elements that are present in that substance. And to do that, we need to make bonds, we need to break bonds, and that will change the number of atoms of each element that are going to be present in the substance. So there are 5 different types of chemical reactions that can be identified based on their chemical equations. That's nice and easy. And then later on in a following video, we'll talk about some other types of chemical reactions. All right. So the 5 general types of chemical reaction that we have are synthesis or combination reactions, decomposition, in which we break up reactions, combustion, single displacement, or sometimes called single replacement reactions, and then finally double displacement or double replacement reactions. Either of those terms can be used, displacement or replacement. So let's go ahead and get started with the very first type, the synthesis reaction. Synthesis reactions are straightforward. We are starting with a simple compound and we're going to make something that is more complex, or we can start with simple elements and make a compound. So those are the basic types, and as you can see here, I will show you, we're just combining A plus B to make AB. We can make from element to compound, like in the process of reacting sodium with chlorine to make sodium chloride, or you can make something from smaller compounds into make something larger. It doesn't have to be one product only. In the case of photosynthesis, which is the equation that I have here at the bottom, you can see that we can react 6 molecules of water and 6 molecules of carbon dioxide to make one large complex molecule of glucose, and then release 6 small molecules of oxygen gas, which is an element. But we have gone from simple molecules to very complex ones. All right. The second type of reaction that we have is the opposite of a synthesis, is a decomposition. We're going to go from a compound that is more complex, and we're going to make simpler particles, simpler molecules from it. It could be going all the way down to elements, or it could be, again, breaking down into simpler compounds. So the general form is AB goes to A plus B, and we can have a decomposition like we have in the case of water. When you pass electricity through it, you can decompose it into its components hydrogen and oxygen. Or you could also have the breaking of a very large molecule, something like a protein, all right? And if you have water in presence of digestive acids, you can break it into its component amino acids. And that's the process of digestion. This is how we get our nutrients, all right? So decomposition is very straightforward. You can see it's going from something that's big to things that are a little bit smaller, that have fewer elements in them. All right. The third type is the combustion reaction. Combustion reactions are reactions in which we are literally going to burn a fuel, some type of compound, and it's normally a compound that's going to contain carbon, hydrogen, and sometimes oxygen. And we're going to react those, and we're going to burn those in the presence of oxygen, all right? And the products of that combustion are carbon dioxide and water, all right? So it's very straightforward to recognize, because you see that you have oxygen, and your products are carbon dioxide and water. So this is very common type of reaction. We use it in our daily lives. We use it, for example, to cook. And the reason why is because combustion reactions always release heat. Right? They release energy in the form of heat, and those type of reactions are called exothermic reactions, and we will talk about that in the video about classifying reactions on the basis of their energy. So here's an example at the bottom. You can see how methane gas reacts with oxygen to give carbon dioxide and water, and again, that's what we use for cooking at home. The fourth type is the single displacement reactions. And single displacement reactions is a reaction in which an element with higher activity will react with a compound to displace a similar element from the compound, and therefore make a new compound and release that lower activity element. So in this particular case, in the A plus BC goes to B plus AC, in order for this reaction to happen, A must be able to displace B from the compound. Otherwise, there will be no reaction. All right. Here is an example of how this works. In the case of zinc and hydrochloric acid, zinc has higher activity than hydrogen, and so the zinc will displace the hydrogen to react with the chloride ion, and so you're going to be left with hydrogen gas being released and zinc chloride being formed. Now, a couple of important things here. Again, one, the zinc must be more active than hydrogen in order for the reaction to happen. And two, once you have formed the ions, basically zinc is going from having no charge to having a +2 charge. All right, that's the formation of the ion. You have to react it with 2 chloride ions in order to make the neutral compound. So remember, we have to continue to keep in mind the crisscross for this to occur. All right, now I've talked a lot about the activity, how whatever element is coming in must be more active than the one that is in the compound. And how do we know that? Well, we have an activity series table, and I'm going to put that up on the screen right now. This is a nice activity series that I have for you. In class, I will hand this one to you guys so you can actually have a copy of it. You do not need to memorize this activity series. This will be given to you in the back of your periodic table whenever we do a test or a quiz. So there's not another thing that you need to memorize, but it is nice to know how to use it. How do we do it? Anything that is towards the top is going to be very reactive, and therefore it's going to be able to displace things. An element such as lithium is not displaced by potassium because potassium is further down, but lithium can displace any of the elements below it. So if you have a reaction, if you're wondering, let's say for example in the case of zinc here, all right, and let's see if we can highlight it for a moment. Zinc is right here, and where is hydrogen? Hydrogen is down here. Well, because zinc is higher than hydrogen, it was able to displace it. But if that was not so, that cannot happen. So if zinc had been below hydrogen, no reaction would have happened. So here's another example of that. All right, if we have the reaction between magnesium and iron, and let's look at where magnesium and iron are. Magnesium is right over here, and iron is right over here. So magnesium, being higher in the reactivity series, can displace iron, but the opposite, iron as a metal cannot displace magnesium from a compound. And here are the reactions that will show you that. Okay, so if you can see that, magnesium as a metal can displace iron, and so iron then leaves as a metal. But if we are using iron to begin with, and we have a magnesium compound, there will be no reaction. There is just not enough activity for the iron to be able to push out the magnesium. All right. Then the final type of chemical reaction of this simple general classification is a double displacement reaction. And those are reactions in which we're going to have exchange, all right, of partners between ionic compounds or between compounds that can form ions. It's like the general formula would be AB plus CD gives you gives you AD plus CB. All right. So notice that I have kept the order. If the substance or the particular element or ion was in the front is because it's normally positively charged. And if it's in the back of the compound, this is because it's negatively charged. So A can replace C and B can replace D, which is what we've seen that there. All right. So it is important that we see that this could actually happen this way. So let's see again. All right. This replaces that, and this can be exchanged with that. So those are the exchanges that can happen. Positive for positive, negative for negative. All right. Now, for a double displacement reaction to occur, we have to have something that's called a driving force, and we'll talk about that in a moment. But let's look at an example first. All right. So, if we have a reaction between sodium chloride and lead nitrate, what's going to happen is that we are going to exchange the sodium for the lead and the lead for the sodium. All right, but again, you have to keep in mind that you have to keep the compounds neutral, so you may need to have more of the counter ions present. Okay, so the products that you're going to get are sodium nitrate and lead chloride. Notice again that we need to have two chlorides to make that neutral because the lead has a +2 charge. So always remember to do the crisscross when you're doing this particular type of compounds. Now, you will also notice that in the starting materials, this is an aqueous solution and this is an aqueous solution. And in the products, we have the aqueous solutions, but we also have a solid. And the solid is our driving force. Right? A driving force is something that traps the ions once they have exchanged, so they cannot go back and continue exchanging back and making reactants again. So in the case of the reaction we have here, the lead chloride traps the ions, the lead and the chloride ions, in the solid, and so they're no longer able to go back and react with the sodium and the nitrate ions. All right, so they cannot form sodium chloride and the lead nitrate again. All right, this driving force can be either a solid or it can be a liquid. All right, and at the bottom I have a reaction in which the driving force is the formation of a liquid. This is a neutralization reaction. We have an acid, sulfuric acid, reacting with sodium hydroxide to give you sodium sulfate, which is soluble, still in aqueous solution, but we also make water. We have trapped the H plus and the OH minus ions in the form of water, and that makes it nice and stable, and so therefore it cannot go back to make the original reactants. All right. So now that we have talked about these 5 types of chemical reactions, I would like you to attempt the following problems. First, try to classify the reactions that we have here, and then try to complete the following single displacement reactions. Now remember, you have to be able to use the crisscross. You know what ions are going to be made, all right? Copper normally makes the +2 ions, so that's what you would make if you're going to make use that. Manganese uses normally the +2 iron, all right? So keep those things in mind. Aluminum would make this +3 ion, but you need to be able to figure this out from your knowledge of ions, from your knowledge of the periodic table, but you must use the activity series that we talked about, and you can see it in your video. You can go back to your video and pause it there so you can answer these questions. All right? Good luck, and I'll see you in class.